All right, good morning, class. We are now in Unit 3. So this is the unit where we're going to start graphing all of our sine, cosine, tangent, cotangent, cosecant, and secant functions. All right, so, yep, I know some of you are already, because you have to graph, but it's all right. So it's a nice method that we go through, and if you follow the method, it shouldn't be too bad. So periodic functions. So many things in life repeat with a predictable pattern, such as weather, tides, and hours of daylight, because sine and cosine functions repeat their values in a regular pattern. They are called periodic functions. All right, so they have a certain length, and then they start repeating stuff like that. All right. Our first function is the sine function. All right. So it's written as f of x equals sine of x. The domain is all real numbers, so from negative infinity to positive infinity. There's no break in it. The range goes from -1 to +1, so that's the height of the graph. All right, and then on the left here is an example of the table. All right, so do it in orange. So I'm going to plot the points that are easy to plot. So I'll do 0, 0 first. All right, and then also given, ignore these couple. I'll go pi over 2 is 1. Pi is 0. Alright, so with our pattern here, so we started at 0, went up 1. The pi over 2 went back down 1, the pi. Then we go to 3 pi over 2, we're going to go down to -1. Alright, and then 2 pi is 0. So if we repeat the pattern on the left-hand side of the y-axis, so we got 0, instead of going up to the right, we're going to go down to the left, back up to 0, down like that. Alright, so the height that this resonates at is called its amplitude, which we'll talk about in a little bit. But make sure you have arrows on these graphs because they do repeat forever. Alright, so the x-intercepts for these graphs are in the form n pi, where n is an integer. So it would be like pi, 2 pi, 3 pi, etc. Okay, and its period is 2 pi. So this means it repeats the pattern every 2 pi. Alright, so switch to blue to kind of illustrate that. So this dotted line area, okay, that's the area that'll repeat itself. So if you just copy and paste and flip and all that, that pattern right there will repeat forever the length of the graph. Alright, and it's symmetric to the origin, as you can see what we did on the left-hand side of the y-axis. Alright, so that's sine. That's what it looks like there. Cosine's very similar, it's just shifted a little bit. So again, here's cosine. The domain is infinite. So negative infinity, positive infinity. The range is -1 to 1. Alright, so we'll plot our points. So sine started at 0, 0. Cosine will start at 0, 1. Okay, and then again, we'll graph the ones that are easy to graph. So pi over 6 isn't on there. Pi over 4, pi over 3. Pi over 2 is though, so we go down 1. And then we go down 1 more to -1. And now we'll start coming back up. So it's like 3 points down, 3 points up. So 3 pi over 2 is 0. 2 pi is 1. So I did that one. So if we want to reflect it to the left side of the y-axis, so we're going down. We'll come back down here. Negative pi over 2 is 0. And then come down to -1. Now we start coming back up. And our graph, cosine looks a little more like a W. This should actually, sorry, my ends. The ends should be rounded down because this is going to repeat again. There you go. All right, so that's cosine. It's continuous. Our x-intercepts are in this format right there. So 2n plus 1 pi divided by 2. As you can see, right there's my x-intercept. So it'd be pi over 2, and then our next one's 3 pi over 2. I meant the right x-intercept there, not 3 pi over 2. Sorry about that. Okay, so those x-intercepts will repeat like that. All right, and again, our period is 2 pi. So, just like cosine, it means in this dotted region right here. All right, this is what's going to repeat the period. All right, and we did the symmetry part of it. So, example 1 is graphing. So this is one way to do it. I have a easier method that'll come up next. But, so from our previous graph, we know that sine of x at 0, sorry about that, is 0, and then it's 1, then it's 0, and then it's negative 1, and then 0. So 2 sine of x, all we're going to do is multiply the sine of x column by 2. Alright, so that number out front is changing its height. Alright, so let's make it a little more steep. So 0 times 2 is 0. I'm going to change colors, right? So times 2, times 2, times 2, and so on. Okay? So I'm going to get 2 here, 0, negative 2, and 0. Alright. So in orange, I'll do the original cosine or sine function. So 0, boom. Alright, it's just going up and down, 1 unit up, 1 unit down, and it kind of repeats like that. Okay. Now, for the new one. So so we still start at 0, 0, but instead of going up 1 unit, we're going to come up 2 units. We're going to come back down 2 units. We're going to come down 2 more units. And then we'll start by coming up 2 units. Okay. Boom. I'm going to come down 2, up 2, up 2, down 2. Alright, so 2 sine of x is just steeper. Alright, so the purple is 2 sine of x, whereas the orange is just sine of x. Alright, so into the next part, got our amplitude. Alright, as I was talking earlier, that's kind of the height of the graph as it flows through it. So our amplitude is always the absolute value of A, and it's the height above and below the graph. Alright, the period is 2 pi over B. And this is how often the cycle repeats. Alright, so this is our little formula for the period. Alright, so this is here. I would copy this down on a sheet of paper somewhere. Okay, this. Okay. Okay, these two things is how we're going to graph everything. Alright, so once we get this, it's super easy, just a matter of plugging it in. It's tedious, but it's not too bad. Alright, so we're written in the format of y equals a sine b of x. Alright, so what we need here is the absolute value of a, Alright, so for our problem right here, oh, sorry. This is what we're gonna graph. Y equals sine of 2x. So here a is 1. So the value of 1 is 1. And then we have our b, which equals 2. Alright, so our period is equal to, I go up 2 pi over b. So 2 pi over b, which is 2 pi over 2. So the 2's cancel out, so our period means this graph repeats every pi. Alright. So the next part, since they're dealing with sine, we're going to use the y equals sine of x right here. We're going to use that. So my left endpoint hopefully I can write small enough to fit it all in here. This is an easy one, so this one's at 0, 0. My first quarter point, so first Q, P, just for abbreviation purposes, is pi over 2b, comma A. So plug in, I have pi divided by 2 times b, which happens to be 2 for us, and my A, comma 1. Alright, so now I have to simplify it. Actually, I'll come back and do that. I'll write all this down, and I'll use a different color to simplify it. So my first quarter point is that. Then we have our midpoint, MP for midpoint, which is pi over b, so pi over 2, comma 0. And then my third quarter point, which would be 3 pi divided by 2 times b. B is 2, comma negative A, so negative 1. Then my right endpoint is 2 pi, which happens to be our period, 2 pi over b, comma 0. Alright, so that's all done. So now let's simplify. So we get 0, 0. I'll just rewrite it in blue to show that's what we're graphing. No changes there. I have pi over 2 times 2, so pi over 4, comma 1. No changes for my midpoint, so pi over 2, comma 0. And then for my third quarter point, it's 3 pi over 2 times 2, which is 4, comma negative 1. And in my right endpoint, 2 pi over 2. The 2's simplified to 1, so it's just pi over 0. Alright, so now we have our points to graph. So now let's graph them. So in my graph, I'll just kind of write, this is pi over 4. This is pi over 2. 3 pi over 4. And then pi. That's all. Basically just write your x values down. That's why we have the scale the way it is. So my first point is at 0, 0. And then I come up 1, pi over 4. And I'll come back down the pi over 2, 0. And then down again, the 3 pi over 4, negative 1. And then back 0. Alright, you see the pattern. You go up, down, down, up. So the next one will be up again. Down, down, up, up, down, down, up. Okay, so that's just stretching the graph over the period. So this is sine of 2x. example 3, we're doing cosine of bx, and that means we have to go back and use the other function. Alright, so we gotta use the left end points were 0a, first quarter point is pi over 2b, 0, so use that right hand box. Alright, if we go back up to it real fast, I'll show box. It's this box right here. This is our cosine box. Okay. So, start off in black. My left endpoint is 0a. I'll write it out since we can't see it right now. My first quarter point is pi over 2b, comma 0. My midpoint is pi over b, negative a. My third quarter point is 3 pi over 2b, comma 0. And then my right end point is 2 pi over b, comma a. Alright. So here we're dealing with cosine of 2/3 x. So here, my amplitude, that's the value of a, which is 1. My b, which is 2/3. So this part will probably throw a mix into our algebra, but it's not too bad. Alright, so let's go purple. Let's start filling these in. So this would be 0, 1. And then we have pi divided by 2 times 2/3, comma 0. And then we'll have pi over 2/3, negative 1. And then we have 3 pi over 2 times 2/3, comma 0. And I'll do the work on the right hand side for these. And then 2 pi over 2/3, 1. Okay. The ugly math. So my first quarter point, I'm doing my scratch work over here. So I have pi over 2 times 2/3, which becomes pi over 4/3. Now we can't divide fractions, so it becomes pi over 1 times the reciprocal of 4/3, which is 3/4, which is 3 pi over 4. Okay, so here we get our new one. What did we say? It was 3 pi over 4. So we get 3 pi over 4, 0. The next one is pi over 2/3. Again, can't divide by fractions, so we multiply by the reciprocal of the denominator. So times 3 over 2, which equals 3 pi over 2. So we'll get 3 pi over 2, comma, negative 1. And now we'll do our next one, 3 pi over 2 times 2/3, which equals 3 pi over 4/3. 3 pi over 1 times 3 over 4. Which will give me 9 pi over 4. Okay, so we got 9 pi over 4, comma 0. I'll get wrapped up in where it's supposed to go on the graph. I'll show you that in a second. So the toughest part, I feel like, for these problems is the actual algebra that we're doing right now. Okay, again, same rule. So multiply by the reciprocal of the denominators times 3 over 2. Okay, 2's cancel out, so we get 3 pi is what's remaining. So we get 3 pi, comma 1. Okay, scratch work done. Time to plot our points. So we have 0, 1, which is, I guess I should use a different color. Go blue. We got 0, 1 right there. And now I'll just write my numbers. So this is 3 pi over 4. This is 3 pi over 2. 9 pi over 4. And 3 pi. So a big thing to know is just how it flows through the amplitude and everything like that. So don't worry about where in the graph everything has to go. So just for instructional purposes, just to, get the flow of what the graph looks like. So then we come down to 0, down again to -1, and our pattern. So down, down, up, up, and then the pattern will repeat itself. Okay, so this 5 points here is your period. So then this repeats. So down, down, up, up, down, down, up, up. All right, and then just connect it, make sure it's smooth. Okay. And this is cosine of 2/3 x. Alright. So we did where the b's are affected. Now we'll do where the a and the b is affected. Alright, so we're back to sine. Okay. So I guess I'll scroll over and use a space over here. So my a, absolute value of a, so a is -2 here, so the absolute value of -2 will be +2. My b is the number in front of x, which is 3. Okay, so this one should look out nice. B's not a fraction, so my left endpoint, I find it, so I'll scroll up again, is 0, 0. My first quarter point, then we'll do our midpoint, then we'll do our third quarter point, and then our right end point. So first quarter point is pi over 2b. A, midpoint is pi over b, 0. Third quarter point is 3 pi over 2b, -a. Right end point is 2 pi over b, 0. Alright, so now we just have to plug it in, Left end point's nice and easy. 0, 0. And then we'll get, sorry, it's not 2 pi. Then we'll get pi over 2 times 3, comma, 2. Then we'll get pi over 3, 0. Sorry, it's going to kind of skew a little bit. So 3 pi over 2b, -a, so -2. And then 2 pi over 3, 0. And just got to clean up anything that we have. Alright, so left endpoint's good. First quarter point will be pi over 2 times 3, which is 6, comma 2. Midpoint doesn't need to be changed. That's pi over 3 and 0. Then we'll have 3 pi over 6, comma negative 2, which actually simplifies to pi over 2, negative 2, because that 3 and 6 simplify to 1/2. And then the last one's good. So I'm going to highlight what we're going to use. 0, 0, pi over 6, 2, pi over 3, 0, pi over 2, negative 2, and 2 pi over 3, 0. So I'm just going to write my x values down. So we have 0, 0. Okay, and then I'll do pi over 6. And then it's pi over 3. So when you're doing your work and you're submitting your work, obviously you guys don't have graph paper. Hopefully you do, but if you don't, not a big deal. So when you just draw out your graph, just make it look like this graph right here. So just draw your little T, okay? And then just put little tick marks along there, you know, about 1/4 inch apart. It doesn't have to be super detailed, but so when you're graphing it. Alright, and I'll show you when I do it by hand as well. Alright, so back to what we were doing. So pi over 3, pi over 2, and then 2 pi over 3. And I need you to do this part. This is very important. Alright, so we have 0, 0. Pi over 6 is up 2. Pi over 3 is 0. So you see that our amplitude A is 2, so that means that's why we're 2 units up, not 1 like the past couple problems have been. So that means we're going to go down 2 units, come back up 2, and this is where the pattern repeats, and now we're going up again 2, go down 2, down 2 again, up 2 to 0, up 2, down 2, down 2, up 2. Alright, so our amplitude just kind of stretches the graph vertically. Alright, and this is negative 2 sine of 3x. Okay, last example. We got our cosine. So let me write down our information, our left. Okay, it's not working right there. Don't know why. My left end point. Ugh, son of a bee. Is 0, A. And then my first quarter point, my midpoint, my third quarter point, and my right end point. So you have 0, A, and then it'll be pi over 2b, 0. Then it'll be pi over b, negative A. And then 3 pi over 2b, 0. And my right endpoint will be 2 pi over b, A. Whoops. Sorry about that. Sorry again. There we go. So, my A is the number in front, so the absolute value of negative 3 is 3. And in my B, this is pi. I'm doing red. Okay, so 0A would be 0, negative 3. Because I'm just looking at the A, so A right here. Alright, and then we have pi over 2 times pi, because B is pi, comma 0. Then we'll get pi over pi, negative A, so it'll be positive 3. And then we'll get 3 pi over 2 pi, 0. 2 pi over pi a, which is -3. So we'll simplify anything we can. 0, -3 is good. Let's go to the other ones. The pi's cancel out. So we're going to get 1/2, 0. Pi's cancel out. Doesn't make 0. Anything divided by itself is 1. So we're going to get 1, 3. And then the pi's cancel out here, so we get 3/2, 0. And then the pi's cancel out there, so we're going to end up with 2, -3. So now everything's nice and simplified. Easy problem. All whole numbers, no pi's. So we have x is 0. This is 1/2, 1, 3/2, and 2. Well, we have 0, -3. Because it's negative, it starts down low instead of up high. And then we'll come all the way up to 1/2. We'll come up 3 more. Back down to 3/2, and then down to -3 at 2. So we'll come back. So to repeat the pattern, up 3, up 3, down 3, down 3, up 3, up 3, down 3, down 3. Alright, so now we'll sketch our sorry, it's not pretty. Okay, so this is our -3 cosine of pi x graph. Alright, so the big things to take from this, guys, if you just use, let me scroll up here, this right here, use this, okay, and that will help. Alright, so our formatting is, I wrote there, y equals a sine b of x. Okay, let me write it again in here for you. So this is y equals a cosine b of x. This is y equals a sine b of x. Okay, that's where your a and your b from. Alright, I'll push the assignment out there in a little bit. Again, email me questions you may have. I'll help you make notes on it.